Ladies and gentlemen, now we move to the main session of today's webinar, which will be moderated by Dr. Ega Adi Wicaksana, SPI. To Dr. Ega Adi Wicaksana, SPI, time is yours.
Okay, thank you, MC. Okay, good afternoon, ladies and gentlemen. Welcome to the Sinntech webinar 34, which is organized by the Department of Fisheries, Universitas Gadjah Mada. And my name is Ega Adi Wicaksono, and I am honored to be your moderator for today's session on a very vital topic, the integrated blue innovation of shrimp production. Okay, to make the time to be more efficient, let's move to our first keynote sessions. We are privileged to have an esteemed expert from Malaysia. Our first speaker is Professor Dr. Murni Marlina Abdul Karim. Prof. Murni is a distinguished academic and researcher. She is currently a professor at the Department of Aquaculture and serves as the Deputy Director of the International Institute of Aquaculture and Aquatic Sciences at Universiti Putra, Malaysia. She earned her PhD in Environmental Science, Aquatic Pathology from the University of Rhode Island in USA. Her expertise are in the aquatic health and disease management. And today, she will be presenting on the topic integrated health management for sustainable shrimp production. So, Prof. Murni, we are eager to learn from your insight. The screen are yours.
Okay, thank you, Dr. Ega. Assalamualaikum. Good afternoon and salam Ramadan to screen. Okay, let's see. Share this window. Okay, can you see that? Dr. Ega, can you see my screen?
Yes, we can see your screen.
Yeah. Sometimes maybe if the line is not so clear, maybe I have to close my video, but it's okay, we try. Okay, so all right. And thank you for the introduction, Dr. Ega. And then for today's seminar, my talk that I will be sharing knowledge about the integrated health management for sustainable shrimp production. So before I start with the talk, let's have a big pictures on the shrimp industry and why farmers choose to farm shrimp. Okay, if we look at our global population nowadays, it's already past 8 billion people. And then it's keep growing. Yearly, I think it's around more than 70 million increasing of the population. And because the increase of this population, so the demand of the protein also increase. And is that enough to feed everyone? You imagine why not cow, why not chicken, and then why shrimp is also very important, because if you see the 2 cow can produce only 1 calf a year, that will not be enough. But shrimp, they are overachiever. 1 pair of shrimp, okay, it can produce at least 250,000 of eggs. And then that's why it's important. And it's a game changer for the shrimp industry. And if we look at the SDG, World SDG, the number 2 SDG is zero hunger. If I'm not mistaken, number 2. Okay, so that's the targets, that's the mission, to make sure that everyone is enough, to feed everyone is enough. And the shrimp farming doing their part. And that is why shrimp farming or aquaculture is very important to the food security. So that's the bigger features and why industry is very important. And then for nowadays, we see that shrimp production or shrimp farming is no longer.
Move your slide.
It's not yet.
Oh, no.
Is it moving now? Okay, all right.
It is still not moving.
Not moving?
Yes.
I did change it.
Okay, it's already moving. Thank you.
It's already okay. All right. Is it moving? No?
I think it is not moving again.
Not changing, right? Can I choose not to share slide or just like this? Is it enough for your view?
Yes, I believe it is enough.
Okay,
Thank
all right.
you.
Okay, thank you. Okay, so now, okay, so now that what I just mentioned just now, so the shop is no longer a small scale industry, small scale activity. So it's a very highly intensified and also the technology driven industry. There's so many technologies for this industry and it even supplied globally. But despite all these intensifications or technology advancement, there's a one problem remain the biggest threat, which is the disease. And many farms profitable maybe 2 cycle and then suddenly they collapse because of the one disease outbreak. So the main question here, how do we prevent the collapse instead of we reacting to that disaster? And that is why integrated health management comes in. It's very important. So as Dr. Ega mentioned that my expertise in aquatic health and disease management, and I have observed most of the disease problem, okay, in shrimp industry, not mainly from the microbiological problems. Okay, there's so many management problems, there are environmental problems, there are system imbalance problems. So that is why we need to think of the prevention method rather than we treat the disease. But the prevention not meaning that it will 100% not the disease is not coming, because it's not easy to prevent disease 100%, but at least we can reduce the occurrence of the diseases. All right. And then when we look at this, the global shrimp productions is according to the FAO 2024, shrimp aquaculture is among the most valuable commodities worldwide, and is also driven by the high consumer demand. People nowadays like to eat seafood. So imagine we know that the poultry industry already stable, it's already surplus, meaning the production is more than demand. But aquaculture is still developing, even though we produce a lot, but it's still not enough to meet the demand. And then what happened in one day if the poultry industry collapse? So people will start going for aquaculture. So it won't be enough. And that's what we say, that there's consumer demand, and also the export market is very huge nowadays. So let's say we know that Indonesia, one of the biggest what we call it exporter for the shrimp, because when I was in the US for 4 years, when I go to the supermarket and when I look for the frozen shrimp, so it's always said that from Indonesia. So we know that how that the Asian countries actually play a role in supplying shrimp and also aquaculture products to the world. And also the advance in the hatchery technology. So many advances, so the university being very actively contribute and also innovate so many things, and then it can be transferred to the farmers, to the industry, and the genetic improvement. Now we have not only SPF, specific pathogen free, we also have SPT, specific pathogen tolerance, and then we have another one which is not coming in my mind. So there's also improvement on the genetic and the feed innovation. As we know that the main cause for the industry is always coming from the feed. So now we have so many feed innovation for the industry, and also we have the intensive and super intensive system. But however, despite all the intensification increases, what else actually increase? So the organic loading increase, the nitrogen waste increase, stocking stress, microbial instability, those are also increased. So while the productivity increases, the biological resilience also decrease. So the industry is becoming strong, but the biological part is becoming very fragile. So that's the challenge. So we see that it's coming up for the production, but the biologically, how we tackle the disease, how we do the management is becoming less, or we say it's becoming very fragile. Okay. And then my slide is in the next. All right. So there's a two major cultured shrimp species in the worldwide. So the first one is a white leg shrimp, or we call it udang putih white shrimp, and we also have the black tiger shrimp, Penis monodon. So globally, is dominated by these two species. And for the vaname, okay, is the production globally is around like 70 to 80%. And why people choose vaname nowadays? Because of the fast growth, and it's also salinity tolerance. Okay, it's this tolerance is better compared to the monodon, and then it's also able to perform very well in high density system. And then the survival is between 50 to 60%. And it's really ideal for the intensive farming. But intensive farming means that you have the high biomass, you have a high waste, but you also increasing the pathogen risk. The disease risk will be increasing too. So what happened to Penis monodon? So Penis monodon is actually longer culture period compared to the white shrimp. So the white shrimp is between to 80 to 90 days, then you can harvest. But meanwhile, for the black tiger shrimp, monodon is taking longer, that around like 120 days. 120 days is the common. Okay, and then but it's also additionally important in Asia because of the price is larger, the market price is very attractive. This is much expensive we compared to the white shrimp. But in the hatchery system, they have a quite low survival. It's between 20 to 30%. I'm talking about the hatchery survival rates. Yeah, okay. But the monodon is more sensitive to stress, and because of this, both the advantage of these two species, the health becoming the main problem. Okay, so the challenges in the aquaculture production is not specific to the only, but to the aquaculture production, it's very common. The challenges, viral diseases, bacterial disease, instability of the water quality. Okay, and then the high density stress, environmental degradation is something that we cannot control when it comes to the environment, and also antimicrobial resistant due to the use of the antibiotic, which is becoming resistant. And then nowadays the MR is one of the biggest topic in the aquaculture. So intensive production system often really exceed the natural carrying capacity, meaning that when you have the intensive production, and then the natural carrying capacity of the water bodies also increase. So when the ecological balance is collapsed, that's why the disease flow. Yeah, so when you not maintaining the both, you maintaining only your shrimp farm, but you not maintaining the environment that near your shrimp farm, then it's actually your shrimp farm can collapse. So that's why it's very important to maintain the environment and also maintain the business. So disease outbreak is usually the final symptom when the system is imbalanced. Okay, and then if we look at here, this is what I say, that when it started the beginning of the shrimp farming in 1986, and then it's keep increasing, and then when the disease spike, okay, Japanese emperor, and then it start to go down, and then we also have a attack on white spot disease for the monodon. So this is where early in the 2000, most of the country we were changing from the monodon to the vaname, to where the vaname started. And then the vaname bloomed very well. Okay, it's increasing very well until around 2012, when the EHP and AHPEN attack the industry, and the production is become lower again, and then now it started to coming up. So now, yeah, they said that most of they also started capturing back the monodon, because monodon now is coming stable again, and then white spot disease is not it can be controlled, can be prevented. People start to carry the monodon. So now even though there's a lot of people that capturing vaname, there's also monodon that catching up the product. Right. So this is the list of the disease that listed by the World Organization of Animal Health. So the major disease include the white spot, and Tara syndrome, yellowhead virus, okay, and myconecrosis viruses. So these diseases share three common characteristics. What are their characteristics that they share in common? The first, most of these diseases are rapid transmissions, meaning can be transmitted very fast, and then it can cause a very highly mortality and no effective treatment to those diseases. So usually there's some treatment antibiotic, but there's not encouraging use antibiotics, and then there's no specific treatment that be very effective once they had the diseases. So in many cases, when the farmers detect the disease, only after the mortality begins. Okay, at this stage, it is too when they start dying, and then you start the treatment, mostly you can only save maybe 20 or 30% of that, or maybe even lower. So treatment-based management is not really suitable when we talk about the shrimp industry. Okay. So the disease outbreak, it's not because of the pathogen itself, just what I said before. Okay, it also interact between three things: host, pathogen, and also environment. So when one is actually in balance, okay, not in the balanced condition, that's where the disease comes. And pathogen may be present in the pond without causing an outbreak, meaning that some of the pathogen is already there in the pond, but it's not outbreak, it's not causing mortality. Why? Because the environment is good, the immunity of the host is good. So disease cannot become an outbreak. So, but when the dissolved oxygen drops, okay, and then the ammonia increasing, the management is poorly applied, the temperatures fluctuate, and then the stocking density is very high, this is where the shrimp find their weakness and the outbreak occurs. So the disease prevention must be stabilized in the environment. So that is why I say that it's better to prevent rather than to cure. And how is actually it transmit? Okay, how the disease outbreak coming is from where? From where it can be transferred. So the water intake also you need to take care. Okay, the equipment and the net, yeah, it need to be sterile, it need to be clean. The boat, the vehicles, the birds, the crab, infected broodstock, live feed. So that is why farm, you cannot avoid or ignore biosecurity, because without good biosecurity, pathogen will enter easily. So this will be from our next speaker. We'll talk, I believe we'll talk deeper about the biosecurity. So that is why farm design and operational discipline are very important. How you design your pond, whether your pond is it near the salt water, what's the most important thing. So before we start the shrimp farming, there's a many factors that we have to look at in order to make sure that we can sustain the farming. So that's going to be another topic, how the selection of the place and everything. So for today, we will be focusing on the integrated farming for the shrimp production. Okay? And then, so what is IHM? What is integrated health management? So it's actually a whole system of the preventive. It's a preventive system approach that required integration of the nutrition, water quality, microbial management, biosecurity, monitoring, and environmental control. Instead of treating the disease after the outbreak, we should manage the risk before the outbreak. At least we can reduce the mortality or reduce the occurrence of the disease. That is why this is very important, because the integrated health management is more focusing on the resilience of the farming itself. So why is necessary? So in shrimp aquaculture, because okay, shrimp is only rely on the innate immunity. Okay, this is the basic immune for the invertebrate and invertebrate. So shrimp is invertebrate, meaning that they only have innate immunity. They have no memory. immunity, okay, they cannot remember their previous infection. It's not like human, like us, we can be vaccine. So when we got the vaccine, so our body already produced antibody. So when the disease comes in, we remember that, and then it can counter back the disease or reduce the symptom of the disease. But not to the shrimp. Shrimp, they won't remember whether that they have been infected before or not. And so because of that, the high stocking density also increase the stress hormone, they reduce the immune efficiency, increase the pathogen exposure. So most of the shrimp disease, it cannot be treated effectively because of this, because of their lack of the immunity, high stocking density, and so on. And if the excessive or the antibiotic use, okay, which is not in a proper way or not following the guideline, so it can contribute to the antimicrobial resistance, okay, export rejection, because most of the country nowadays, I think like 100% of the country, they don't want, they reject, okay, any animal that use the antibiotics, and the environmental contamination. So preventive health strategies is the only sustainable approach in order to protect the shrimp farming. Okay. So the key principle of the integrated health management, what? So the core is a prevention is better than cure, as what I mentioned before. So the early detection, okay, because when you detect it earlier, you can reduce the economic losses. Okay, or if you have a proper management system, and then you unlikely, like the risk to have the disease is smaller, and you have to minimize the chemical and the antibiotic use, a healthy environment, okay, which will help affect the health shrimp, and long-term sustainability over the short-term gains. So this is, you have to think. Some people, they are okay, this is their first cycle, they're doing very well, and then they start to increase the density, use the antibiotic. It won't be sustainable. Okay, so we have to put the sustainability first before anything else, right? And what's the core component of the IHM? So biosecurity is important, water quality and environmental management. You have to look at the nutrition and the feed, what type of feed that you use, whether that, how much that you feed your shrimp, whether you whether you feed them enough, whether you feed them too much or too little. So those things also very important. The keeping of the record, the monitoring, the surveillance. Most of the shrimp farming, my observation, they don't have a proper record, which is, that's the most important thing, because from the record you will see actually what happened and what trigger, what contribute to the outbreak of the farm. And then the disease control and intervention also important. And functional nutrition, okay, so feed is not only for growth, okay, it's also the health tools. And because of that, we have so many different tools, biological tools that we use in order for us to make sure that we are running our farm in a good manners, or reducing the risk of the outbreak. So functional ingredient include that, which is something that we can add to the feed, okay, sustainable feed management. So we can add to the feed is probiotics, we have prebiotics, symbiotics, postbiotic, immunostimulant. So these ingredients is actually able to help in improving the gut microbiota. So everything disease actually most of the time is coming from the gut. So healthy gut is actually we becoming a healthy shrimp, healthy people. So the gut is very important. And also enhance the immune readiness. Okay, reduce the pathogen colonization. So gut health, the gut health is actually equal to the shrimp health. So that is what probiotic, prebiotic, immunostimulant, and postbiotics is actually doing. So when we focus on the probiotics, okay, probiotics are beneficial microbes. So when it administered into the host with the right amount, yeah, you cannot take it less, you can take it more. So in the adequate amount, then it will confer a benefit to the host. and they are actually how they are working. They are colonize the gut. Okay, colonize. Okay, it's able to compete with the pathogen. It's produce antimicrobial compound. What else is improve nutrient digestions. It's able to enhance the immune gene expression, and also probiotics actually is create a microbial dominance in the gut. So if the beneficial bacteria dominate the gut, the pathogen will be struggle to multiply. So when it struggle to multiply, so the disease will reduce, or there no disease at all. And then how we apply the probiotics, okay, is either you can capsulate, incorporate it into the feed, you can bio-encapsulate into the live feed, immersion, multi-strain probiotic being used. Nowadays in the packaging, they are not only one strain, they use multiple strain because they said that multiple strain is actually better, yes. Because let's say if you have 4 strain in your packaging for probiotics, let's say one died, you still have 3 that can be functional. If two died, the strain died, you still have 2. But if you use one single probiotic, only one species, if one died, so there's no longer probiotics in your system. Okay, so this is what I just explained before, and then how it works. It can provide as a supplement, and then it can reduce the multiplication of the probiotics, colonize, and then it cause a beneficial effects. And how about the prebiotics and symbiotic? So probiotic is very common, prebiotic is very common, and then now they're coming up with the symbiotic. So the prebiotic is non-digestible ingredients, non-digestible substrate. So they feed on the bacteria. So usually they say that prebiotic is actually food to the probiotics. So when they call it symbiotic, it's combination of the probiotic and symbiotic. So that's what we call it, symbiotic. So the symbiotic is to ensure that the better colonization, stronger microbial balance. So microbial stability, able to reduce the disease susceptibility. So they are not only using the probiotic. Some they use probiotic, some they use probiotic combined with the prebiotic, because the prebiotic can trigger the growth of the probiotics. Okay, now they also have one, okay, there's a postbiotics. So postbiotic is also, there's a lot of research coming up for the postbiotic, especially in the university. So they are actually inactivated, what we call it? They are inactivated microbial cell or membrane, okay? It doesn't mean that it need to derive or coming from probiotic. It can derive from any of the microorganisms. So the microbial cell or the metabolite can coming from any of the bacteria, not specifically to the probiotic itself. So the advantage of the postbiotic is no risk of live bacteria overgrowth because they are not using the whole bacteria. They use only the component of the bacteria. It's more stable on the storage. And then the culture system is simpler, so you don't have a lot of media to culture them, and it's still able to stimulate the immune response. So it's also one of the emerging innovation in the shrimp health. And then it's immunostimulant. Okay, this is quite common. Okay, what actually they do, the immunostimulant does, is actually is able to activate the innate immune mechanism. So by taking the immunostimulant, they're able to increase the hemocyte activity, phagocytosis activity, they're able to increase or trigger the enzyme production. So since that the shrimp is lack of the adaptive immunity, they don't have the memory, so immune must be ready. Okay, so the innate immunity must be ready, and that is always must be at the very high level. That is why the immunostimulant also play an important part and also very beneficial to the shrimp industry. Okay, biofloc technology. This is been in the industry for so many years, long ago, biofloc technology, and it's still been doing it now. It's quite a very tricky method because you need to know the balancing of the microbes in the bioflocs. Okay, so it actually a system. Biofloc technology is a system that converting nitrogen waste into the microbial biomass. So it turned into something beneficial that can become at feed to the animal, or at least it can actually improve the environment. So they can be able to decrease the pathogen microbial loads, and also able to treat the pathogen. So this biofloc it can be acted as a bioremediation, which is control the environment. And some people say that the biofloc, the microbes in the flocs, also able to become as a probiotics, but we don't know, because in floc there's a lot of microbes. So we don't know which microbes contribute to the beneficial effects. So they also act as the additional protein sources and also pathogen suppressor. So we don't know, because there's a lot of microbes. So some of the scientists or people in the university, when they had the floc, sometimes what they did is actually they tried to culture bacteria from the flocs. Then they have to screen which one is beneficial. That's a lot of work, because once you're culturing the biofloc, you get so many different species, so many different strains of the bacteria. So that's why the biofloc is quite complicated in terms of the numbers of the microbe. But once in the stable system, is actually it provides beneficial effects to the shrimp industry. However, okay, that is why the biofloc is require a very proper management. Not everyone can do biofloc. So without the aeration, and if you don't know about the ratio of the carbon and nitrogen ratio, you don't know how to control it, the system most probably will fail. So you have to make sure that you know the carbon and nitrogen ratio, and also you have enough aeration when you want to try the bioflocs. So biofloc mechanism, the key elements for them is the sources, of course, and also the carbon and nitrogen ratio, as what I mentioned before, continuous aeration, microbial aggregation. So the microbial will aggregate, and then they feed on the carbon source. There's so many different carbon sources that they use. Sometimes they use molasses, sugar, and different things. Okay, and then it also need a proper management. Okay, and because it need to maintain the low ammonia, okay, stable community, reduce pathogenic bacteria. So this biofloc, we can say, is a both tool. They are also taking care of the environmental, at the same time they're also taking care of their health. Because it can be a bioremediation, it can also be a probiotics, it become also feed. So there's many different type of what we call it activity that can be done by the bioflocs. And the biofloc, see sometimes how actually the bacteria works. Okay, they are mostly heterotrophic microorganism. The bacteria actually, they are talking to each other. So when they are talking to each other, we call it antiquorum sensing. So when they talk to each other, they can work together, they become a microbial aggregation, then they form the flocks. So that the flock that we can use shrimp. So it's also act as a water quality improvement. So meaning that the bacteria able to reduce the ammonia, okay, and then it convert to the nitrates, and also it goes to the nitrogen gases. So that's the thing, that the system that we need to see. We have to understand before we decided to use any of this technology, any of this method. We have to make sure that we study and we know how it works, and we know how to manage that, because the microbes can be sensitive, and is also very smart. Sometimes that people say that, oh, I use this probiotic in my farm and it works, but it's not work in a different farm. Why? So because microbes, they interact with the environment. Maybe the environment, they are different. The temperature is different. Okay, the water quality is different. The culturing system are different. So those also actually contribute to the difference. Okay, different, what we call it, different effects of each of the technology. Right. So then, okay, there's so many things that a lot of like a vaccine, nanoparticle, but for today, I think since that we also have very limited time, I'm only focusing on the sharing the knowledge on the only the 4 methods only. So the disease management in aquaculture. So the prevention is always been, yeah, we are talking about the prevention a lot. Okay, we have to make sure that we do the preventive measures, we take care of the hygiene, also the vector control, biosecurity, water treatment, waste management, and then monitoring, antimicrobial stewardship monitoring, and also early detection, targeted treatment system, environmental management. So this is how we want to manage the shrimp industry. So this is only one layer of prevention. All right. And yeah, this is what I just mentioned before, right? Okay, the prevention strategies that you have to make sure that the pathogen-free water that you use, okay, free food, handling, okay, make sure you handling properly, the transportation, vector and pest control, very important, biosecurity, the quarantine after you get the larvae, the post-larvae, or maybe from the brood stock, you have to make sure that you quarantine first before you use it, and then regular cleaning and disinfections, selective breeding also important, the source of the water. Okay, that's also important. I think that's the main thing that you have to look at before you think about to open shrimp farming. And then this monitoring and surveillance. Okay, so the water quality management, so the beneficial microbes, okay, they able to decompose the organic waste. Okay, when you have the beneficial microbes in your ponds, it's able to compete with the pathogen, it's able to stabilize the nitrogen cycle, and also able to prevent the algae bloom. So water microbiology determines the farm stability. You have to make sure that you have to know that microbe is everywhere. That's why we said that microbe is ubiquitous, meaning it everywhere they have a microbe. Okay, even on your table, on your phone, and even in the water, there's a lot of microbe. So you must know how you want to make use of it, and you have to maintain the numbers of the microbe. It's all about the water quality management, farm management, and how you control that. And then the health monitoring surveillance, okay, that's another layer of the preventive control instead of what I just mentioned before. So you have also different monitoring tool. Okay, they have food safety, okay, gap, biosecurity. So this is the entry. Before that, with the monitoring tools, you can also use PCR diagnostic. You can use PCR to detect your virus. You can do regular sampling. Okay, water parameter logging, okay, record, and also mortality tracking. So this is very important so that you keep track what happened. So, okay, so today, okay, when there's a lot of raining, the shrimp starting to die, when the temperature is fluctuation, okay, there's also increasing in the numbers of the shrimp. So those things are very important. So the good aquaculture practices, okay, the risk is actually coming from the inside of the farm or outside of the farm, whether you have the monitoring or control record, whether you have the sanitation control plan, and also the biosecurity framework, okay, which is coming from the outside of the farm, the access control, the feed source, quality, safety. So those the another layer of the preventive method that you need to take care of. It's not only the microbes or the pathogen that you need to take care, the environment, the biosecurity, also you need to take care of that. All right. So biosecurity, the how it's actually the roots, how it's coming to the farm. So there's so many different way. Okay, the water entry. Okay, the water. This is the easiest way. Okay, the water entry, the stock entry, the worker movement. Okay, and then the equipment sanitation, meaning that you are not cleaning it right. You are sharing the equipment from one pond to another pond, one tank to another tank. And then also wildlife vectors also important. Okay, the bird, okay, the frog, and anything that in the farm you also need to control, and that's another layers of the biosecurity that able to reduce the exposure to the disease. Okay, so the standard biosecurity, human, equipment, water, fish, vector. So this is thing that you have to take care of. So you have to make sure that you have a proper management, proper system to make sure that you have all things scheduled rightly. You have to make sure that your equipments are already clean. Not only equipment, the pond tank, the clothes, the vehicles, so the water intake, whether is it right water outlet, the source of the water, whether the water is import, you must make sure that you have a treatment of the water, you monitor the flow, the control, the record keeping, and also the quarantine, and also all the vector that you need to take care of. Okay, so the farm biosecurity procedure. So you have to take care of the site, water, parameter, stock, and also record maintain. So the site selection is important. Okay, you have to make sure that you select the right site away from any of the agriculture activity, okay, away from any of the pollutions. And the first main thing is that enough salt water for you to start your shrimp farming. So water intake, when you discharge, when you intake the water, okay, you need to keep it for some time to make sure that sedimentation is already down, okay, and then it's safe to use the water. When you discharge the water, make sure that you have a treatment pond. After you treat your water, then you can discharge, or else, okay, you will getting back the bad water that you already discharged. That is where the disease coming from. And also the parameters, you have to make sure the movement of the people in your farm, the vehicle, the outside that enter the farm. Okay, stocking, make sure the quality control. Okay, you took care of the quality, the fry, the brood stock before entry, whether it's a good one or not, before you do the stocking to the ponds, and then also the record maintained. So this is the biosecurity procedure. And yeah, and then I think this is the last of my slide because 7 minutes more. Okay, so this is benefit of the integrated health management. Why? Why is important? Because it's reduce the disease outbreak, because you prevent it early. You know, you observe earlier, and then you lower the antibiotic use, because we are no longer, like in Malaysia, it's totally banned. There's no antibiotic that allowed, unless there's, I think, maybe 2 that allowed, but with prescription. You need a prescription by the veterinary. Okay, and then improve the survival rate, and it's better feed conversion ratio. FCR is very important, okay, to make sure that when you do the farming is worth it. And environmental sustainability, higher long-term profitability. And because of this, sustainable shrimp production required the whole system stability. Everything need to be stable. Anything need to be taken care of. So because medicine alone, it won't able to save the farm. The keywords that you need to know is that preventions, the balancing, and also the integration. So these things are very important. So if you know how to prevent, if you do the prevention, you know how to balance, and then you integrate the health management system in your ponds, in the business, then you reduce the number of the diseases. Okay. Oh, okay. So with that, thank you very much. I hope that at least I share something. The knowledge is beneficial to all of you. Thank you.
Okay, thank you very much, Prof. Murni, for that comprehensive and insightful presentation on stream health management. Okay, I believe some of the participants already raised their hand. Yeah. But for
Okay.
make the time to be more efficient, we will move to the second session first. Yeah.
Okay, sure.
And we will keep the discussion session at the end of the Sinntech.
All right, thank
Okay.
you. All right, thank you, Dr. Ega.
Okay. Moving on to our second session, I would like to inform to the audience that our second speakers, Mr. Muhammad Syaifudien Bahry, is unfortunately unable to join us live today due to an urgent matter. However, we are committed to providing you with his valuable insight and he has kindly prepared a video presentation for us to watch together. But first, I will introduce first Mr. Muhammad Syaifudien Bahry is the founder and CEO of PT Aqubeta di Pojaya. He holds the master degree in marine science from Universitas Diponegoro, where he granted cum laude, and he is a specialist in aquaculture biotechnology, especially focusing on the development of prebiotic and prebiotic for shrimp farming and environmental health. And he will present his presentation entitled The Blue Biotechnology Innovation in Biosecurity Management for Sustainable Shrimp Production. So for the technical team, please play the video presentation from Mr. Bahry.
Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, distinguished guests, ladies and gentlemen. It's an honor for me to be part of the Sinntech webinar hosted by Department Fisheries, Gadjah Mada University. I would like to extend my gratitude to the Dean of Faculty of Agriculture, Bapak Jaka Widada, PhD, or his assembled representative, and also through the Dr. Sulis for the continuous support of the forum to the bridge of academia and industries. But I'm apologize for the not being able to attend in person due to the some matters that I must prioritize. But however, it's not the diminishing. Also go out to the all academic researchers, lecturers, students for Gadjah Mada University, as well as all the participants join us with online. Thank you for being here. My name is Muhammad Syaifudien Bahry. I'm a founder and CEO of Aqubeta Indonesia, Blue Tech startup based in Semarang, and today I'm excited to share our journey and innovation on the topic of blue biotechnology innovation in the biosecurity management for sustainable shrimp production. For those unfamiliar with an Aqubeta, is a blue biotech startup. We are dedicated to providing innovative natural-based probiotic solution for the shrimp farming and the broader aquaculture industry. Our core mission is to tackle the most pressing challenge in aquaculture with the solution that inspired by ocean itself. So, why our innovation is necessary? The shrimp farming industry faces significant threat, especially in the diseases, particularly EHPND or early mortality syndrome, or we call the EMS in the after the publication. As we know that from the some country, the shrimp production is getting lower and lower day by day because of the disease, and the economic losses is devastating. So the core of the problem is often an uncontrolled density of pathogenic bacteria, especially in Vibrio genera, and its cause mortality rate goes up 100% within an hour, a night. So what are the solution? Aqubeta doing a research from 2018. Start from this research, we isolate the powerful marine fungal we identified as a Trichoderma raceae marine strain that we get from the Makassar archipelago from the respondent and Scora. It's how it's potential because it produce a high level of active enzyme like amylase, cellulase, and protease, which are crucial improving feed digestion in water and water quality itself. And a more important thing, they can produce strong antipathogenic activity that against a Vibrio strain, which cause EHPND. So in our field study, it's shown up to 98% reduction in the pathogenic bacteria appendix. So in this slide, our initial screening results confirming of the enzymatic and antibacterial activity of the isolate. And the microscopic and molecular identification was confirmed. We were working with the potential Trichoderma raceae strain, and for that isolate, we developed a kind of revolutionary probiotic. The firstly is antivipro that dedicates to reduce the pathogenic density, especially in fibrous in the water, and Aquaprofit that designed to foster the great immune system as the gut bacteria. Actually, what Trichoderma do in shrimp pond? So they dominate water and hepato, and they avoid the negative bacteria to make a quorum. So we want and we don't need more chemical treatment or even replace the antibiotic uses in troubleshooting problem in our pond. We use the three domination approach, like competition nutrition space and antibiotic antimicrobes compound production and active enzyme. So for further analysis using GCMS, we find 20 bioactive compounds from this funnel, and among them we collect more potential strains compound with natural surfactant and alkaloid. There are natural compounds that help the control bacteria, negative bacteria population. The second one, our innovation, the red flag innovation we call the Aqubacillus. It's a consortium of three marine bacillus strain, which are Bacillus pumilus, Mycoides, and Savensis. And for that isolate, we formulate this consortium to be the safer and more sustained alternative to avoid the chemical uses and antibiotic. So the interesting thing, all of this isolate, we isolated from the mangrove ecosystem in Semarang that basically is the polluted ecosystem that surprisingly that can produce tremendous active enzyme and compound to compete the pathogenic disease. And this as a result in our field tests have been remarkable, and control challenge test before treatment, all the pond is positive with HPND by PCR, and a week the data shown that the pond 6 treated with Aquabacillus shown that EHPND infection was resolved within just a week. And this graphic shown that the pond 6 treatment with Aquabacillus shown that more stable proportion of the beneficial green algae. So compared with another pond, there are unstable fluctuation in another pond. And in short, is our treatment effective to reduce the fibrio and to stabilize the phytoplankton in the pond. And for that innovation, our portfolio combined with the hand-on-hands technical assistant for the farmer for a complete one-step solution for aquaculture can be succeed. We guarantee that every product we manufacture and we products is the environmental friendly product, efficient and effective. This integrated approach ensures not to be held for the stream, also for the sustainability for the entire ecosystem. And we offering with the different kind of partnership with all of the participants. But we want to talk more specific to the B2B joint research and tech enabler. So this came illustrated that ideal collaboration ecosystem. We would invite all of inventor with a patent approved technology that has been validated in pilot scale. We are also looking for the tech enabler university, researchers institution, and the governor body who can facilitate and support the industrialization of our innovation and our development product. We also together can serve to find the potential market and the technology adapter for the farmer. And this illustrated how our technology bring from the lab to the industry with the brilliant inventor technology of Aqubeta. In our journey begin from the researchers from the SMT institution like Diponegoro University, Unsud University, and BRIN. And this is a testament to what happened when the academic researchers or research institution meet with the entrepreneurial vision or a startup. And this moment we specially invite the Gadjah Mada for revolutionary aquaculture product, and I hope this spirit can of the spirit of the academic and industrial collaboration is what we want to continue for the further step. And please do not hesitate to contact me direct on reach out in our company. We are looking for any discussion. And finally, let's collaborate, let's innovate, let's build the truly sustainable future for the shrimp production. And thank you for this time. Thank you very much your time and your attention. Wassalamualaikum warahmatullahi wabarakatuh. Be part of the biotechnology revolution with Aqubeta. Thank you.
We will jump first into the discussion. I ask the permission from all of the participants and also Prof. Murni.
Yeah, sure.
Okay, for the discussion, I will give the opportunity first to Mahasri Gunanti that has already raised her hands. Please.
Salam Prof. Gunanti. Masih ada Prof? Mungkin Prof sudah tiada tuh.
Okay, Prof. Gunanti. Okay, and then we will move to the question at the chat box first. Okay, Prof. Murni.
Oh yeah, on the chat board. Oh, okay.
Okay.
What's the question?
Okay, the first question is from Nurfianto Pangidung. The question is, do shrimp cultivated in a biofloc system or controlled environment aquaculture require specific superior varieties that can adapt to these conditions?
Okay. It's at the chat box, right?
Yes.
Okay. Let me see the questions. Sorry. Okay. Did the shrimp cultivated in biofloc system control eco-expect? Oh, all right. So yeah, I must say yes, because when we cultured the shrimp in the biofloc or in any of the control aquaculture system, maybe outdoor or indoor actually. So the selective bred superior lines, such as we have to make sure that We have the shrimp that actually tolerate to the high organic loads. Okay, it able to perform maybe under the very crowding environment. It need to show a very high immune resilient and also able to at least efficiently utilize the microbial biomass. And most of the species commonly used is a vaname, udang putih, because it's already have a baseline trait that's suitable for the system. So biofloc ini it's not only monodon. Some of people also start to using the modern for the biofloc, but mostly people are using the commonly is vaname. So that is why I said that we have SPT, specific tolerance, SPS, specific pathogen resistant. We have SPR, SPT, and also SPF. So those is the three things that usually that people will buy lah. Orang akan beli. Kalau dia kata postlavenia ini memangnya SPT, memang sudah datangnya genetic modificationnya specific tolerance, very tolerant to the environment. So it's gonna be a very good one. So the selections, the superior lines is very important for the bioflocs. So, right? I hope that I answered the questions from Panggidung. Yeah.
Okay, really interesting, Prof. Murni. So, is the feeding habits are one of the concern if we want to cultivate the commodity in the biofloc system?
What
Feeding habit.
what is it? Lee, what do you mean? I mean,
The food and feeding habit.
the feeding habit.
Yeah.
Yeah. Okay. Because the biofloc also can serve as the feed to the shrimp, okay, to the aquaculture species that we use it. So the feeding habit also something that you have to look at, because some of the shrimp, okay, they also have behavior that they don't want to eat. It's depending on the situation, the environment. But the feed is very common. Okay, there's a feed that common, the pellet are very common. So, but when it comes to the bioflocs, okay, it's actually some of the biofloc, they are able to increase the appetite of the shrimp. So the feeding behavior also, we also have to look at the feeding behavior too. Not only the specific tolerance of the shrimp. But the feeding behavior we can only see once we already culturing the shrimp. So that's actually after you do the stocking. Right?
Okay, thank you. Is Professor Gunanti has already joined with us? Not yet. Okay.
Not yet.
How about the operator, Anissa? Is the video already ready to continue? Not yet.
Yeah. And also, Dr. Ega, I have to leave by 3:30 because I have to pick up my kids from school. Because
Okay,
Ramadan, they
okay.
finish early.
When you have to leave?
By 3:30.
3:30. Okay.
Yeah.
Okay, then we will continue for the question and answer session. Yeah. The next question is from Rausan Fikri. What distinguishes traditional integrated health management, which usually lead to often delay intervention, from the modern integrated health management, and how long it considered to be delayed?
Okay. So the traditional IHM such as is a more reactive, meaning that it's already happened and then they react to that. And also based on the visual sign, okay, mortality, our observation, and also by periodic sampling, meaning that a weekly sampling, bi-weekly sampling. So we have to look at, and also the intervention after the outbreak. So when they already there, the outbreak there, then baru kita akan buat the intervention and how we want to prevent it. So it's often usually it act after the immune suppression and also after the pathogen already proliferate, and then they have progress. But for the modern IHM, is more it's more proactive and also more predictive. for the IHM. So it's a real-time monitoring. So you can see the water quality, the behavior, the biomarkers. So that is the modern IHM. And it also give you early warning signal of the IHM, and a preventive intervention before the mortality. So it's more on the preventive that you can reduce, then you can manage it before the disease coming. So it's also act as a stress or early deviation stage, meaning that you are maintaining or you are providing lesser stress, okay, before the mortality started or anything. So when you call it what is considered as a delay in intensive shrimp farming, I can say is that it is more than 24 to 48 hours after you see the first signal of the disease, the clinical sign, they can call it delay. Okay, it's more than 24 hours. Maybe that, okay, within the 24 hours, you already see that they are not really eating well, the behavior of the swimming already not there. So, but then you delay to 24 or more to 48 hours, we can call it delay. But after you see the mortalities is appear more than like 30%, okay, and then I can call it, it's definitely you are delaying the signal because it's more than 30%. And but in a very, let's say in the case of the bioflok, so in the high density bioflocs, even if we said that you are not kamu tidak aware of the symptom between 12 to 24 hours, you can actually increase the disease outbreak because the bioflok also have a pathogen. They have a lot of microbes, so it can be triggered from the different microbe. So that's the time of the delay that we consider as a delay in the detecting the disease and so on. All right. Salam Prof. Alim, I can see you.
Waalaikumsalam. Yeah, thank you very much for joining this webinar. Yeah.
Yeah, thank you for inviting.
Okay. Thank you for joining us, Prof. Alim. Yeah. So, Prof. Murni, I believe it is really interesting about the integrated health management. Yeah. But the problem is when we want to diagnose the disease in the shrimp farm, of course, since you tell us that a lot of parameter can be taken from the environment to judging the condition of the disease, is there any general symptoms based on your experience when the symptoms is really indicate that there is an early
Something
warning?
is not right with the shrimp.
Yeah.
Usually it's by looking at the feeding behavior. When you feed them, they are not really eating. So when you do the sampling, you check the gut is a half, it's not full. If they're half gut, but you already give enough feed, and then when after you feed them, and then you see that a lot of feed has not been eaten. So that's actually a very easy things to see because you feed them every day. So you look at their feeding behavior. And sometimes since that kolam tu kan tidak nampak udangnya, jadi you can also see how it looks like, the color of the shrimp. Usually the color is going to be very silver, nice silver, okay. And then kalau ianya pale, that's the thing that clinical sign that you can see. Sometimes you can see from the tail, the color of the tail. But the most easier things to see is usually they looking at the feeding. Yeah.
Okay, thank you for the answer.
Yeah.
Then we will move to the next question from Ephraim Ovandiping. So the professor, thank you for the insightful presentation. We know that integrated health management relies heavily on maintaining the optimal culture condition. However, with the current challenges of climate change making weather patterns increasingly unpredictable, which specific environment parameters do you consider the most critical to prioritize in order to prevent the shrimp immune system from collapsing during the sudden extreme fluctuation in the temperature or salinity?
Okay, so meaning that which parameters that we need to consider to prioritize. Okay, so under sudden temperature shock or salinity shock. Okay, the most important parameters that we need to prioritize, meaning when there's a temperature shock or salinity shock, so our the immune system will be triggered. So we need to prevent the shrimp immune from collapse. So what we need to take care of, we look at the parameters, the dissolved oxygen. The oxygen need to be enough because when the immune system is decreasing, actually the oxygen is something that we need to take care of. That's very important. The same way with humans. Sometimes kalau kita anxiety attack, so you know, kitanya suka bernafas. So we need more oxygen. Okay. So and the second that also important that you have to take care of is the ammonia. You have to look at the ammonia reading. Whether if it's increasing, is high, it's actually it can contribute to that challenges. Okay. And then the ammonia need to be under controlled environment and also the pH. So there's a very basic water quality lah. pH, salinity, stability. But salinity is the least one parameters. Okay. But usually when the temperature shock coming is usually because of the rain. So it is because of the rain. So you have to check the salinity. So the salinity might be dropped. So you have to make sure that you change the water and so on. And then maybe TSS, okay, total suspended solid. That is if you use the bioflux, okay. So to keep that TSS is within the optimal operational range, okay, within the range, and also to access TSS during the temperature spike. So you have to make sure that because when the total suspended solid is increased and then the temperature is increased, so the respiratory, so the oxygen, they are competing for the oxygen. The shrimp competing the oxygen with the microbe. So those also things that you need to look at. That is some of the important parameters. I hope that I answered the questions. All right.
Okay, thank you, Prof. Mari, for the answer. But I'm a little bit curious. So one of the most significant aspect is also the TSS, suspended solid.
Yep.
So in the shrimp culture, is there any optimal range for the TSS? Because a different system production, of course, will lead into a different suspended solid. And also, if we talk about the shrimp that is cultivated in the bioflux, of course, it will be cultivated in a really high value of the suspended. Is it will affect the immunity or the health condition of the shrimp when we cultivate in the bioflux system?
Okay, the first question is what is the optimal range? So if we talk about optimal range of TSS, is actually is depending on the size of the shrimp farm, whether it's a semi-intensive or intensive system, because the range is different. But I don't really remember the range. But I don't know, Prof. Halim, correct me if I'm wrong, okay? Maybe if the extensive or semi-intensive, it should be between 100 to 150 milligram per liter, because it's really depending on the size of the system, okay, the ponds, okay, the density and the size. And the second one, the question is?
How about in the bioflux system, when the production system must be in the really high value of suspended solid, I believe. It will affect the shrimp also.
Okay, in bioflux system itself is already have a lot of microbes. So it also can contribute to the TSS. So usually in the bioflux system, the TSS is more, lebih tinggi compared to the system that not using the bioflux system. So yeah, range-nya lebih tinggi. And that is why when you want to use the bioflux, you must have a proper management. Your management tu kena lagi alert, because you are using microbes, the whole bunch of microbe to the place that have also a lot of microbes. So you have to make sure that they can work together, and then the flock that you use is in the right amount. So kalau flock itu kan kita harus tengok flocknya itu berapa. Then a specific amount need to be at the specific size, specific condition, the stocking density of the shrimp. Yeah. If you not manage properly, the aeration is not enough, the carbon ratio not enough, the biofloc usually it fail. Yeah, it's very depending on the aeration and also carbon and nitrogen ratio. Yeah.
Okay, thank you, Prof. Murni. So the operational procedure is the key to
The key, yeah, management. Management is always is the key, the problem. Tadi saya sudah nampak Prof. Gunanti.
Yeah,
Prof.
has
Gunanti masih?
Prof. Gunanti already joined us?
Yeah.
Okay, or other
Prof.
participant? Is
Prof.
there
Gunanti
Gunanti raise hand.
raise hand kan tadi?
Yeah, Prof. Gunanti raise hand.
Yeah, already raised hand, but I don't think
Oh yeah, okay.
she in the run. Okay, so I believe 1421. So the last question, I believe, for Professor Murni. Is there any participant that want to ask the question to Prof. Murni?
Prof. Alim jangan tanya ya. Prof. Alim harus jawab soalannya.
Thank you. Yeah. Yeah.
Lagi expert Prof. Alim itu.
Okay, so there's no participant that want to ask the question. Then I would like to ask the last question, Prof. Murni.
Yeah, sure.
I really interesting that you already showed that the aspect of nanoparticle, I believe, yeah. The nanoparticle that is integrated into the shrimp integrated health management. So could you explain more about the aspect of nanoparticle in the aquaculture?
Okay. So nanoparticle is considered the new things. Okay. So because I have one of my colleague that doing the research on the nanoparticle where it's actually include the nanoparticle in the probiotics and also it's include the nanoparticle in the feed. So nanoparticle, the size is very small. Now what's the challenges for nanoparticle is how to produce it a lot on the nanoparticle. And then so usually that nanoparticle what they do is actually they have the most common that been studied, like what my friend is studying is, I'm not mistaken, is the zinc silver nanoparticles. Okay, and then they also have the zinc oxide, and then it's coming from the chitosan. So those are the example of the nanoparticle. So the application is actually it's the same as a probiotic. So some of nanoparticle, they say that they have an antimicrobial properties. They are able to kill the pathogen. They are able to work against the vibrosis. And then their mechanism is actually the nanoparticle. The mechanism somehow they're able to describe what's the research that I remember the result is that they're able to describe the cell membrane. Okay, and also they're able to actively generate the ROS. Okay, reactive oxygen species, right? ROS, right? Okay, and also they also said that maybe this is what I read from the article. The nanoparticles actually is also able to interfere with the DNA replication. So that is how it works. It can also becoming a immune modulation. It's actually when we talk about IHM, mostly the system or how they work is actually more or less the same. It's actually that we are using the different type of the things that we use, like probiotic, prebiotics, postbiotic, symbiotic, so nanoparticle. They are actually like a vaccine. They actually, how they work is actually a common working system. The most common one is actually they always interact with the immune system. So that is also how the nanoparticles working. So that is based on my knowledge and then from what's my colleague been doing now. So, but we are having the difficulty to produce a lot of the nanoparticle. They are very small, and then it's not easy to get it. And then one of them also doing from the chitosan, and so it need to be extracted. And we also need to see whether it's compatible with the probiotics that we use, because the one that we use is that we incorporate in the probiotic, another one is we incorporated in the feed. So when we incorporated in the feed, it don't really give problem, because the feed to tak interact with the nanoparticle. But when it comes to the microorganism, some of the microbe, they interact with the nanoparticle. So we have to make sure that is compatible to use together before kita just assume we combine and then we give to the shrimp and then we give a beneficial effects. So the first step that we need to see the compatibility between those two. Yeah, that's a seed nanoparticles.
Okay, thank you, Prof. Murni, for the insightful answer. And thank you for a wonderful discussion sessions. So I believe this is the end of the discussion sessions. And I have an information for the community that the virtual video presentation from Mr. Bahry will be shared to all of the participants through the email after this Sinntech. Okay. Then, ladies and gentlemen, we have come to the end of our Sinntech. We have learned so much today from the academic perspective of aquatic health with Prof. Murni, and also in the perspective of industrial biotechnology from Mr. Bahry. So I want to thank our speakers for their time and expertise, and to all of the participants, thank you for your active engagement. And I hope the knowledge shared today will help us all to contribute a more sustainable shrimp industry. So have a wonderful afternoon, and I'll give back to the MC. Thank you.
Thank you to Dr. Ega Ade Wicaksana, SPI, for leading the discussion, and our sincere appreciation to our distinguished speaker, Professor Dr. Murni, Marlina, Abdul Karim, and Muhammad Syaifudien Bahry, S.Kel, M.Si, that have enhanced our understanding about how to integrate blue innovation of shrimp production. As a token of appreciation, we will now proceed to the awarding certificates to our speakers and moderated by Professor Dr. Insinyur Alim Isnatsetyo, M.Si.
Okay, thank you.
Professor Dr. Alim Isnatsetyo, time is yours.
Okay, thank you very much. Prof. Murni, thank you very much for your very, very exciting speak in this afternoon. It is a very, very good chance to mine the knowledge from you. Yeah, and it is also very, very important to make the good collaboration with our university. And the next, I hope you can visit us and talk again. Now it's online, but we hope the next is offline here.
Yeah.
Yeah.
Prof. Alim jemput aja, jemput Kak saya ke sana, saya pasti pergi.
Yeah. We have a national seminar on in July, I think. So I will very appreciate if you can visit us here.
Yeah, sure.
In this seminar. So I would like to deliver the certificate for Prof. Murni, and please receive this certificate. Thank you very much.
Okay, thank you, Prof. Alim, and thank you to Universitas Gadjah Mada and Faculty of Fisheries for the invitation. I'm very honored to share just my little knowledge with all of you. Sometimes I'm also nervous to share in front of Prof. Alim, which is much more senior, okay, because we already share the same stage. And yeah, hopefully to meet you guys offline. Yeah, just feel free to invite. We will definitely to fulfill the request. Thank you so much, everyone. Thank you, Prof. Alim.
Thank you.
Alright, thank you.
Juga pada Bapak Muhammad Syaifudien Bahry, terima kasih banyak atas insight yang sangat menarik, dan mohon nanti juga diterima ini ya Pak Bahry. Kemudian juga kepada Pak Ega, terima kasih sudah memoderatori ini semuanya, jadi bisa berjalan dengan baik berkat Mas Ega. Terima kasih Mas Ega. Mohon diterima sertifikatnya.
Ya, terima kasih kembali, Prof.
Oke, waktu saya kembalikan kepada Mas Faiz Mazin, silakan.
Thank you, Professor Dr. Engineer Alim Isnasdo, M.Si, and the operator. Ladies and gentlemen, we have now arrived at the end of today's Sinntech webinar. Before officially closing the event, we will have a group photo session, and we kindly ask all participants to turn on the camera and give your best pose for the photo. Okay, to all the participants, if you can turn on the camera and give your best photo, we have a group photo session before we close the Sinntech webinar. Okay, I will count down from 3 to 1. 3, 2, 1, smile. Okay, once again, 3, 2, 1, and trim. Okay. Okay, thank you. And now, ladies and gentlemen, we have reached the end session of the Sinntech 34th webinar. On behalf of the organizing committee, I would like to express our deepest gratitude to our speakers, moderator, and all participants for your valuable participation. We would also like to kindly remind all participants to complete the attendance from the chat box from the operator. And we hope the knowledge and insight we share today will be beneficial for our future academic and professional endeavors. I am Vice Masin, your Master of Ceremony. I sincerely apologize for any shortcoming during the event, and thank you for your attention. We look forward to seeing you at the next Sinntech webinar. Wassalamualaikum warahmatullahi wabarakatuh, and Ramadan Mubarak. Thank you.
Selamat
Waalaikumsalam
berpuasa.
warahmatullahi
Waalaikumsalam.
Selamat menuju berbuka puasa ya.
Selamat. Ya.
Mari.
See you.